Okay, this is question 25 in Year 8 Circles Revision. In this question, you're asked to find the area of this figure. Now, this is a composite shape. It's made up of two shapes. It's made up of a square, and then we've got a semicircle, which is half a circle, on the end of it. So I'm just going to draw those two shapes separately. So we've got the square, and we don't have a full circle, but we have a semicircle. So what I'm going to draw a full circle there, and then I'm going to put a semicircle here next to it. Okay, so I've just drawn them there. So what we need to work out to find the area of this shape, we need to work out first what we'll do a full circle first. Then we'll do the semicircle, and then we'll do the square. So the dimensions of this circle, but we know this distance here, so we're actually given the diameter, the distance all the way across the circle. So we're told that the diameter is 6 meters for this circle. When we do area of a circle, the formula is area equals pi r squared. So if the diameter, the distance from the top to the bottom, is 6, then the radius is 3, and we need the radius for the area of a circle formula, which is area is pi r squared. So what we'll do that area of a full circle first. So we've got our full circle, and we've got area equals pi r squared. So I'm just writing here full circle. Area equals pi r squared, which is pi times 3 squared, because that's the radius. And the answer we get when we put it into the calculator is 28.2743. Now, we don't need the full circle, we need half a circle. I know I've drawn this one the wrong way around, but if I actually just cover up the other side, then that's the same as that side there. So I just want the area of this half circle. So that's half a circle. So all we do, our area from here for the full circle, we just want to go divide by 2, and that's the area of our half circle. And now we just need to find the area of this square. And we know that the dimensions of the square are 6 by 6. So I can just write them in. So therefore the area of the square is 6 times 6, which is 36 meters squared. So now for my total area, I just add this half semicircle here, 14.137, and my 36. So my total area therefore is 14.137 plus 36, which is 50.137 meters squared. Now we need this to the nearest square meter. If we round that to the nearest whole number, it would be 50, because that 1, which is after the decimal point, is less than 5. This is question 26. Now we're told that Richard ran around a circular track of radius 30 meters. I'm just going to draw a diagram of that. So we've got a circle track there, and the radius is 30 meters, so I've just drawn that in. And we're also told that Tracy ran around a circular track of radius 20 meters, so I'm just going to draw that in as well. So this is what Tracy did. So her circle's got a smaller radius of only 20 meters. And now we're asked, how much further did Richard run? So if we want the distance around the outside of the track, what we want is the circumference of the circle. So just remembering, there are two formulas for circumference of a circle, and those formulas are circumference equals pi d, or circumference equals 2 pi r. Actually, I'll just put them up here. Now we can see that we've got the radius of both these circles, so we're going to use the second formula, circumference equals 2 pi r. So what we'll do for the large circle, we'll work out the circumference of that circle. So large circle circumference is 2 pi r, which is 2 times pi times 30. And when you do that on the calculator, you get 188.4955. We'll do the same thing for the small circle, work out the circumference of that. Again, small circle, circumference is 2 pi r, which is 2 times pi times 20. The answer for that is 125.6637. And so how much further did Richard run? You want to do this larger distance minus the small distance. So the difference between those two answers is 62.8318. We need it to the nearest meter, which is to the nearest whole number. So 62 point, we need to look at this 0.8. This 8 is bigger than 5, so it's actually closer to 63 metres. So our answer for this question is 63 metres. Now for question 27. In this question, we're asked to find the area of the shaded region. Now, we can see that we've got a rectangle here and that two circles have been cut out of it. So to find the area of the shaded region, we need to do the area of the rectangle minus, so we need to find the area of the rectangle, and then we're going to take away, so I'm going to go minus the area of the two circles. So I'll just set that up. Okay, so area of that rectangle minus the two circles. So I'll just put the dimensions on the rectangle that it's 10 by 24. Okay, so first we'll do our area of our rectangle, which is just, sorry about that. So the area of our rectangle is 10 times 24, which is 240 centimetres. I'll just put that 24 in there, it just seems to have moved. And then we can work out the area of our circles. Now the formula for the area of a circle is area equals pi r squared. We can see that we've actually got the diameter of each circle. So we know that the diameter of the circles is 5 centimetres, but the formula for area of a circle needs the radius. So if the diameter is 5, the radius is 2.5. So therefore the area of one of the circles is area equals pi r squared, which is pi times 2.5 squared. I'll just work that out on my calculator and I get 19, that the area of one of those circles is 19.63495. So that's the area of one of the circles. So now we need to find the area of the shaded shape, and the area of that shaded shape will just be the area of the rectangle minus the area of these two circles. So I'll just do that now. So once again, our shaded area is the rectangle area, 240 minus one circle and minus another circle, because we're taking two circles away, which is 200.7302. We need to round that to 2 decimal places. So we look at our third decimal place, which is a 0, and that 0 is less than 5, so it stays as 200.73 centimetres squared. Okay, now for question 28. In question 28, we're asked to find, for this figure, the perimeter. So these dotted lines are actually not on the outside of the shape. The outside of the shape I'm going to trace now. It's a half a circle and another half circle and another half circle and another half circle. So basically what we've got, a half circle and a half circle. I've got one full circle and another half circle and another half circle is two, in other words, we've got two full circles altogether. So to find the perimeter, basically what we want to find is the circumference of two circles. So I'm just going to draw them here. So that's what we want. So what we'll do, we'll work out the circumference of one circle first, and then we can just double it. So let's look at what we've got. We've got the diameter of these circles, because we've got the distance across there. So that's actually, when I put the two circles together, I end up having the diameter of the circles. So the diameter of the circle is 3. We can actually use that actually. I don't need that the radius is 1.5. So the diameter of the circle is 3. And let's just look at what circumference formulas we have. So our circumference formulas that we can choose from are circumference equals pi d or circumference equals 2 pi r. Because we've got the diameter d, we're going to use the formula circumference equals pi d. So I'm just going to write that down here. So circumference equals pi d, which is pi times 3, and when we do that on our calculator, pi times 3 is 9.4277. So just put that there. So that's the circumference of one of the circles. Therefore, the perimeter of both circles will be 9.4277, and you can either go plus the same thing, or you can just go times 2, because there are two circles there with the same circumference. So the perimeter will be the 9.4277 times 2. And just doing that on your calculator, we get 18.8495. Now we need that to 2 decimal places. That's what we're asked to give it to for the answer. So it will be 18.84, or will it be 18.85? It'll be 18.84 because we look at the figure after the 4. So the third decimal place is a 9, which is bigger than 5, 5 or more. So the 4 in front becomes a 5. So that's the perimeter of that shape. Now, in the next part of the question, we're asked to find the area of the shape. Now, we need to see what the shape is made up of. So we need all the space inside. We can see that we've actually got a square in the middle. Okay, if that's 3, this is also 3. There should really be equal markings on it, but it's not saying that it's anything different. So we're going to assume that they're both 3. So basically what we've got a square where that's 3. And I'll just put that the other side is 3 as well. So again, we're asked to find the area of this shape, and it's made up of a square, which I've drawn down here, and we've got a semicircle and another, actually let's look at this semicircle up the top and the semicircle down the bottom. Those two make up a full circle, which I've drawn there. And then we've got the 2 circles on the side, the semicircle. One semicircle there and another semicircle there. If I join those 2 together, I end up with another full circle. So the area of this whole shape is the square plus 2 circles. Now I'm going to move this screen down so that we've got a bit more room to work. So I've just drawn the shape here again. So again, we've got the square and the 2 circles. Right, let's start with the area of the square. Now we know that's fairly straightforward. The area of a square is 3 times 3, which is 9 meters squared. Now we look at the formula for the area of a circle. Now there's only one formula for area of a circle, and it's area equals pi r squared. We can see that we don't have r in this case, that we have the diameter. So if the diameter is 3, then the radius is half of 3, which is 1.5. So I'll just write that down. So I've just brought that in there, that the diameter that we've been given is 3, so the radius is 1.5. So we need to use r is 1.5 in these formulas. So I'm just going to put that down here, that the area of one of the circles is pi r squared, which is pi times 1.5 squared. Just doing that on the calculator, I get 7.0685. Now we've actually got 2 of those, so our total area is going to be 9 plus 7.0685 twice. So you can do times 2, or you can just add it in twice, which is what I'm doing here. And we can just work that out on our calculator now. And the answer that we get is 23.1371. Now we need to round that to 2 decimal places. So we look at the third decimal place, which I've highlighted in yellow. The third decimal place is 7, which is 5 or higher. So therefore the number in front, which is the 3, now becomes a 4. And the answer is 23.14 meters squared.